And next up is the derivative of the inverse function of cosecant of x, and this is the last derivative of an inverse trigonometric function I'll be doing throughout this series. And the steps for how you do this one is very similar to how you do the inverse of the derivative of the inverse of secant of x. So of course, you take the cosecant of both sides. This is equal to x. You do the derivative of both sides, and derivative of cosecant is cotangent multiplied by uh, cosecant. And of course we have to apply the chain rule since it's not an x inside, it's a y inside, and we're multiplying with respect to x. So the inside is dy dx, and all of this is equivalent to 1. So now let's divide negative cotangent of y multiplied by cosecant of y on both sides, and this is equal to negative 1 over cotangent of y multiplied by cosecant of y. And since y is just the inverse of cosecant of x, cosecant of y will of course just be uh, equivalent to x again. Such is the nature of inverse functions. If you have an inverse function of the function, you just get back whatever you plugged inside. Cotangent of y, and then again I'll explain this in the same manner as I explained the derivative of the inverse function of secant of x, since cosecant of y is just equivalent to 1 over sine of y, and sine of y is just equivalent to the opposite over the hypotenuse, and 1 over O over H would just be H over O. And let's draw a triangle, and let's call this angle Y, and we know that the H over O was equal to X. So instead of calling this hypotenuse H, let's call it X, and let's call the opposite side length 1. Well, what is cotangent? What is cotangent of y? Well, that's just the adjacent side over the opposite side, which is 1. So this is equal to the adjacent side. But what is the adjacent side? Well, we know that a squared plus 1 squared should be equivalent to x squared due to the Pythagorean theorem, and therefore we have a squared is equal to x squared minus 1, and a is just equivalent to the square root of x squared minus 1. So therefore cotangent of y is a over 1, which is equal to a, which is just the square root of x squared minus 1. So of course this would just be negative 1 divided by x, as we have here, multiplied by the cotangent, which is the square root of x squared minus 1. And the same thing applies here as with the derivative of the inverse of secant of x. When you plug this into a calculator, you still might be getting an absolute value around the x. And the reason to why is very similar as to the last time. Okay, so sorry, let me just erase here. Sorry, that takes a bit of time. At one point, uh, remember that cosecant is just 1 over sine of y, and the inverse of cosecant is just some angle, and everywhere where the inverse of cosecant of x is defined is between the minimum and maximum of sine. So, and say the minimum of sine is -1 and the maximum of sine is 1, but that would correspond to the angles pi halves and negative pi halves, which is just this half of the unit circle. And at one point in our equation, we had cotangent of y multiplied by cosecant of y, and that's just the same thing as cosine of y divided by sine of y multiplied by 1 over sine of y. And look at this. Since the inverse of cosecant of x is only defined for angles which cosa only defined for angles of the right side of the unit circle, cosine of y will always be positive, and sine of y, and even if sine of y is negative, it gets multiplied by another negative of itself. So let's suppose that sine of y is equal some negative number, but if we have some negative number multiplied by some negative number, you end up with a positive number. Even if the angle would correspond to a negative, even if the angle of sine of y would give us some negative number, it would be multiplied by itself another time and would end up with a positive value down here. So all of this, if we take all of this, will always be in. Let's move the minus to the outside. All of this will always be greater than 1, and a way to prevent that, and a way to prevent it from becoming negative would be, then again, to put an absolute value around the x.